Welcome to the Control Engineering webcast, How to Build IIoT Data Streams, sponsored by InfluxData. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to get the most from today's webcast. If you're experiencing issues with your slide or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded and you will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of this webcast. Now we will hear from the sponsor of today's webcast, InfluxData. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation.
John is the Cloud Ops Manager for his company's SaaS offering. The system is being overwhelmed with all the metrics coming from the SaaS infrastructure, containers, applications, databases. It seems like it's coming at him from everywhere, and he needs to find a way to make sense of it across all these disparate sources. He needs a solution that can detect anomalies, provide insights, and let the business act in real time while it still matters. It needs to be able to handle the workloads which are growing exponentially, keep the customers happy, and help him ensure that the systems are performing at their peak. It needs to work with everything he already has, no rip and replace, and it needs to be easy to use, easy to change, easy to scale. It needs to provide the fastest time to awesome. That's not too much to ask, is it? He has already tried a bunch of different solutions, including traditional SaaS monitoring solutions, Cassandra, HBase, Elasticsearch, MySQL, and MongoDB, but none of them were built to solve John's problems. John doesn't have time to think about building his own time series database. Enter InfluxDB. InfluxDB Cloud was designed from the ground up to provide a highly scalable data ingestion and storage engine which is efficient at collecting, storing streams time-sensitive data, making it easy to query and visualize the data and send alerts all in a completely hosted, top-notch cloud environment. It allows for availability on demand and is kept up to date with a top-notch team of SREs, ensuring SLAs are met and systems are all functioning efficiently. Now John can focus on things that are important to his team instead of managing a time series database while still resting easy knowing he has access to a monitoring system, dashboarding engine, analytics service, and an event and metrics processor. With InfluxDB Cloud, John can sign up and be up and running in just a few minutes with access to all of the data he needs. If you're like John with more metrics and events data than you know what to do, try InfluxDB Cloud for free at www.influxdata.com/products/influxdb-cloud and find out how other customers like John have done to get more out of their data.
Now I'm happy to introduce today's distinguished speaker. Craig Hobbs is a solution engineer. He's a solution engineer at InfluxData. His specialties include solution architecture, project management, proof of concept design and development, software customization, technical training, extract, transform, and load ETL automation, application integration and deployment. Craig has a Bachelor of Science from the University of Illinois, Urbana-Champaign. Craig, thank you for joining us today, and please go ahead.
Thank you, Mark. Thank you for that introduction, and welcome everyone to our talk today on working and building IoT data streams with open source solutions. As Mark just introduced, my name is Craig Hobbs, and I am a solution engineer at InfluxData, where I've spent the past 2 years working and helping customers with time series use cases, IoT workflows, and data stream processing. A consistent theme that I hear from our customers when working with them on site is that they're looking for options and solutions that are really operational friendly and user friendly. So solutions that will allow them to work with their data and make life easier from an operational standpoint. And that's really where I come in to really sit and work with our customers to help them better get the most value out of their data and processing throughout their enterprise. So with that little background on myself, today I really want to focus on the challenge being faced by industrial automation and how they're working with the data streams that are coming from the factory floor, from the shop floor, from the various devices and sensors that make up their industrial environment, and also how we can leverage open source solutions to really make game-changing options based on leveraging this stream of data, specifically working with OPC-based data, and then finally kind of walk through what a solution would look like for leveraging these open source options. So putting together a quick solution there. So kind of just starting with some of the obvious here, and that is that the world of IoT is time series data. So it is that fast-moving, ephemeral data that's based on time, ever-changing, always temporal, with a constant stream of updates. And with that, we've really moved into a state where we've equipped all of our machines and devices and sensors with telemetrics. So that is a huge update for the entire industrial automation world, where every machine now does not roll out without being fit with some way to stream or provide metrics from that device. And even more so, we're actually looking and retrofitting devices. So options and devices that weren't originally aligned with this type of telemetrics are now getting retrofitted and updated. So what this sensification, if you will, is starting to create is a large stream of data that is coming from all of these different devices and physical sensors. And from that, we're now starting to see how these machines are being connected and asking the questions, what are we really getting from the value of all this data? And that kind of segues into the next point here, but around the sensification of the physical world, and that really becomes the simple question of how. And that is, how do organizations now start to tap into the potential of all of this time series data, all of this streaming data that's coming from the physical sensors and devices? And as they begin to tap into it, how do they take advantage of it both on the job? How do they take advantage of this data, this stream of data across the enterprise? And probably most important, how does it make a difference for customers? So really kind of bringing it back to equipping all of these devices. What's the benefit and value that I can now bring back to my end customers? Today we're able to get some of this data from traditional systems like historians, but that's still very limited in how we can access those historians and move that data amongst the enterprise and move it amongst the different silos and specialties across the enterprise that want to make use of this data. So really kind of seeing that there's a gravity of data out there within our industrial automation factories and shops. But now, how do we really tap into that data? How do we move that data around, use it for different data scientists, use it for different business analytics, use it for job performance and improvement, all of the different things that really come with the promise of sensorifying all of our devices. So kind of moving on to the next piece of our story, and that is a look at OPC. So for all of my pre-millennials here, the phrase of, are you down with OPC? So for all that are not, what OPC is to us is that communication framework for industrial automation. So it's really the machine-to-machine communication exchange that we see in the industrial automation world. So here's kind of the start of our challenge. We have everything sensorified. We have everything with telemetrics data. Now let's start to understand how we can access that data and meet that challenge. So kind of a brief definition on OPC and just a little bit of background. So OPC itself is an original standard that was established for reliable data exchange and communication in industrial automation. So really dating back to the 90s, the standard was originally created to be platform independent and allow that information flow between machines and devices. Unfortunately, the standard was actually created based off of Microsoft Windows technologies such as COM and DCOM objects. So that made adoption from new services, new architectural services, and technologies very difficult. So what we have now, what we have been in the early 2000s, is a change in that classic OPC, and that gives birth to what we now have is OPC-UA, with the UA being that the recognition of a unified architecture. So now we have this unified architecture that allows for a go-forward plan with new technologies, new web services, publish and subscribe services, client-server architectures, all the things that we're used to for communicating across platforms today. The UA standard and framework now opens up all of those different channels, and to that we have a foundation that supports and contributes to this standard that's made up of several different companies, manufacturing companies producing and creating the different devices and sensors that go into these factories. So now we have this great go-forward plan that opens up everything and allows this stream of data to come pouring out. And that kind of brings me to my story of the lonely windmill. I always tell this story, and this comes from working with one of our turbine operation companies, where they're actually working through the various use cases of the different turbines that are stationed out. And in engaging with the customer, I was able to see quite clearly some of the issues that they're experiencing. While they now have access to some of these different standards, kind of really sitting down and talking through, what's kind of that next level for them. And what they look at the next level with their turbines is a couple things. Everything from the physical to the actual data that's in use. So from the physical world, our lonely windmill does cause certain hazards. One of the hazards being shadow flicker. So if you've ever been around a windmill and you see the blades beginning to turn, they create those shadows on the ground. And that phenomenon is called shadow flicker, which actually is a hazard. It does cause physical ailments that can be measured, and for that, these types of operational companies do their best to limit that shadow flicker or limit those operational hours where that might be a hazard. Also, considerations such as weather. As the weather and the temperatures drop, ice can form on the blades of the turbine. This ice can then be thrown from the turbine and cause damage to infrastructure and individuals within the area. So lots of physical concerns just in the operation of the windmill. Moving back, then there's the actual data that comes from the windmill. So everything from trying to understand its performance life, any manufacturing updates that need to come from this, being able to send information and automation commands back to the windmill. So everything really related to the data, the functionality, and performance now of the windmill. And all of this was done by a single operator who is looking at the information both from the standpoint of a local historian, but also from the physical presence of going out to the windmill. So all of these physical concerns, all of these data concerns are happening in this lonely windmill story. And there is just this one individual operator who's moving back and forth to try to make sense of all of the data that's coming in. Some of the data is from the windmill. Some of the data is just from the external world around the windmill. So much that goes into this, and they're looking now with the open eyes of, if I have access to this new standard, this unified architecture, how can I now solve some of these problems? So working with that now, we sit down with the wide-eyed optimism that we have OPC-UA, and all of those types of problems will allow us to be more proactive and engage with the data and start to address these types of concerns. But from the onset of creating the OPC-UA standard, it really provided organizations with choice, but no help. So now you have choice of being able to access this data in many different ways, but no direct help. And that help is the idea of that help really comes from the vendors themselves. The vendors themselves do not monetize the idea of this data. So when we think about now, this data is out there, there's so many choices for accessing this data, vendors are not looking to monetize. They are focused on their actual creation and production of the assets themselves. So this leaves organizations and enterprises with lots of questions on, where do I go next? And they wind up locked into the use case and patterns of the vendor themselves. So whatever the vendor has produced to allow them to look at, interact with the data, becomes the extent of what they're working with. There are traditional systems available today, such as historians, SCADA systems, for interacting with that data, but they absolutely come with a lack of interaction and interoperability across the enterprise. So it leaves our lonely windmill case with, I'm getting more data, but I don't know how to use it. I don't know where to go next with it. I know there's an opportunity there for me to unlock some deeper value and use some more modern tools around my enterprise. So these are the questions that are now coming from this. So with that really is where we open the door for open source. And this is where open source solutions really kind of fly in to bring out innovation and answer that wandering that we have from these types of operational organizations and shop floor demands. And that is by providing an attractive alternative for traditional complex solutions. So when I look back at solutions such as historians, where they were limited in their ability to really present the data, share the data, shape the data across the enterprise, now I can bring in open source solutions and combine them together to create options that are cost effective, with a fast ROI, that scale, that are secure, and provide a level of freedom. And that freedom being that now organizations, again, can choose what is the best solution based on their needs. They don't need to subscribe to a single one-size-fits-all solution with many different components that you now have to deploy. You can really target the area of your use case. So in our particular setup, getting access to that data stream, being able to alert and answer the questions that are coming from something like our lonely windmill, and then start to spread that data around our enterprise. So open source really provides a new frontier of working with this type of information.
Craig, pardon me. I know we have the Q&A session at the end, but before we get to that, I have a question. How widespread should data collection be? Should every plant floor machine collect data? How should people decide? And while you consider a reply to that, let me remind those watching that they can submit questions for you using the Ask a Questions function on the interface.
Thanks, Mark. And great question to kind of discuss, and that's also a very popular question that comes from customers that I engage with. And the answer is really with open source, it provides you the ability to take all the data in. So much of the current solutions today depend on sampling of data, or what we call loosey data, just approximations of what's happening on the floor with the various devices and sensors. But with the right combination of open source solutions, there's no reason why you wouldn't bring in all of the data. And with all of the data, you can create a completely different picture of the performance, the life of the various assets and resources that are on the floor, and start to create competitive advantages around your resources. And that comes from being able to access all of your data. There's absolutely situations where single events from devices and sensors would make more sense, and that can really come with further tuning and investigation. But this really opens the door to gather all of that data. And we see a huge advantage for organizations in being able to leverage that. And with that, there's several combinations of solutions that can really address this type of challenge. Again, creating that data stream of time series data, creating a shape and moving that data around the enterprise. For this particular approach and use case, I chose a couple different combinations, really based on the challenge that was put forth, and I'm using the example from the wind turbine operational challenges as well. But I started with Apache NiFi, and for those who are unfamiliar with Apache NiFi, it's also an open source project that's designed for integrations with data workflows and automation tools. So Apache NiFi is a very popular project from the Apache project, and delivers a complete solution for sending and receiving data and transforming that data in a really friendly environment that's a drag and drop graphical environment. It's plug and play as part of its open source background, so you can continue to enhance it. Out of the box, it comes equipped with all the tools and processors that you really need, and really provides a on-the-fly kind of design. It can be deployed at the edge or on a full server, so really flexible, and also comes with other security and scalability options kind of based on your use case. And I always think of Apache NiFi as kind of a easy, clean canvas for anyone of any skill level to just simply begin to say, I want to move my data from one system to another in a reliable, secure stream. So Apache NiFi provides that feature functionality. I next pair Apache NiFi with a time series database from our start of all things in IoT, our time series. And for that, I've chosen InfluxData. There's absolutely many different options for time series backends on the market. I like InfluxData. Not only does it meet all of the needs we've discussed, it also comes with some direct integrations with Apache NiFi. So right out of the box, you'll be able to just plug that up in that same kind of quick and easy interface. It also provides other features that are very attractive to the enterprise use case, being able to move data around the enterprise, able to shape that data. We talked about the volume of data coming in, so knowing that Influx will scale to whatever volume of data we come in, and then also some other nice features around alerting and aggregation. So those are the two components of the solution that I really brought together. A couple more just tidbits about InfluxData, everything from its ability to ingest data and query data at very high speed. So you can imagine now, as we're starting to look at that use case, we're going to be diving into the ability to read that data, visualize that data, and act on that data. So all of this now coming from that stream that we've built from NiFi. And ultimately, we wind up with, in a solution like this, is what I always see as a real easy button, if you will, for kind of creating a reliable data stream. So, and that's really what we're starting with, and that's using NiFi to establish a connection to your OPC-UA server, and bring the data in from NiFi. You can perform any additional transformations. If that were what you're looking for, you don't have to. You can simply just, again, ingest all of that data directly then into Influx. So from our reliable stream to guaranteed delivery in a platform that can take the full fidelity of all of the data coming from your shop floor or your automation. It also provides for this whole set scalability, and requires no coding or development work at all. So, and that's another real nice piece of it when I get to talk to customers who are looking to deploy these types of solutions, because one of the things that really creates a bit of friction is the idea that I don't want to have to go out and buy or purchase a heavy solution that needs to be deployed through the use of either the vendor themselves or expensive professional services. With open source now, I can actually deploy this. I can deploy this simply with simple support from the community. Open source generally is geared around the idea of empowering the end user. So it's not geared toward let me bring in a lot of services, a lot of work. It really focuses on what we call time to awesome, which is being able to deliver these solutions independently by yourself, connect them up, and be running in days as opposed to months. A few other just kind of notes around combining of open source solutions and some of the advantages that come from them. I talked a little bit about the need for development and coding, that it's not there. You're able to kind of work directly with the solution. Community support, really open and shareable. You'll get to understand everything about it without needing to engage directly with a vendor or any other service provider. And security is always very important in these types of solutions. Open source provides a high degree and high availability of solution. But I think the thing that really comes to me is I get away from the vendor lock-in. And now going from that idea that I've had the vendors, I have the various vendor products and devices, but I am not trapped in the limiting setup and use cases that they've defined for the data they're collecting. I can now bring that out of those devices, out of the vendor themselves, and move it about my enterprise and use it in different and creative ways that will create a lot of high value for my organization and operation, and ultimately bring it back to customer value. So, I want to talk a little bit just about basic setup of a solution, kind of combining Apache NiFi and InfluxData, and really just kind of showcase the idea that this is something that can be easily brought together in a few steps, a few operational steps. And what really makes this, and that's really what makes a solution like this so attractive, is how fast it can be brought together. So I'm really able to just kind of talk about the quick and easy steps that bring the solution together really fast. And that's really more the value of open source. I've chosen these particular components, but there's so many different, again, options and available to you. But this really kind of brings it together really fast for that high value, to solve that ROI question that we often get about how long is this going to take, how much investment is this going to take, how much background, how much knowledge do I really need to have on this setup. With this type of combination, it's easy to go directly from the OPC-UA server itself into NiFi that will establish that connection, establish that data stream, both securely and provide data provenance, which will guarantee that receipt and delivery of every message that's coming from your shop floor, and then have that data ingested and collected in a background like InfluxData, a purpose-built time series database for high ingestion and query. So now I can bring all of that data in. I'm not sampling it. I can then begin to do all of the things that I was looking to accomplish, from monitoring the data to now triggering additional automations. I can even start to bring in other data that's not part of the physical world of my shop floor. I can bring in data related to weather. I can bring in data related to other dimensions that are outside of my physical world and start to compare them together and shape and bind them with this data. So that's the other big plus of being able to use a time series platform that allows you to really kind of integrate that data. And then finally, sharing that data in a manner that's appropriate across the enterprise. So whether you're the operator at the wind turbine or you're a business analyst within the enterprise, I can now get that data, shape it, and form it in a way that's useful to everyone who has access. And then kind of just looking at how this would come together, I've kind of talked about the solution itself and how I would bring it all together. I just want to talk about the operational steps that really bring it together and how quick this kind of comes together. So from the deployment of NiFi, the NiFi comes with what it calls processors. These processors allow you to quickly link together different workflow sets. So we'll have a workflow set that is gathering the data from your OPC server, bringing that data in, and then follow that with a workflow set that writes that data off into Influx. And you'll see really quickly here that it's only a few options that you need to add to really be up and running in a matter of minutes. So from this standpoint, starting with the two operators for collecting data, NiFi comes along with two operators. One is for getting the data, getting the nodes from the OPC server. So I think this goes back to the earlier question, should I get all of the data from my shop floor? And I always start with yes. So with this, you can just start to gather all the data from your shop floor. In time, you may find that you want to further refine that, and you can take that road at that time. But start with gathering everything that you need. And then a second processor for then, after gathering that data, then writing that data along. And that's what they call the OPC get data. So now I've selected the data I want. Now it will simply get that data. The next kind of component is to drag and drop these processors onto the canvas. Again, I described the kind of the NiFi world of just kind of having your own paint canvas where you can just simply say, I want to do this, and let me connect those together. So really simply, I want to look for data in my OPC-UA server, and I'm going to look for all of it, and then I want to go get all of that data. So I can simply drag those two processors onto my canvas, and then end up with what you see here, which is just a single slice of my NiFi workflow. And this slice does all of the work of creating that stream of data. This stream is now secure. This stream is now guaranteed data. So this is what I would refer to as a reliable stream. I know it's secure. I know all the data is guaranteed. I have a full data provenance on this, and I can actually check that data provenance using NiFi. So at any time, as the data is streaming in, I can go in and see exactly what the value of all of that data is. That's a real nice feature of NiFi to be able to look into what they call their flow files and understand what's going on. Again, if you're unfamiliar with Apache NiFi, all of these become additional options and features that just give you confidence that you're getting the data that you expect. Otherwise, it's just everything that's moving through the workflow. From there, I can then begin to create the workflow for writing out my data stream, and this now becomes adding in InfluxData. So Apache NiFi comes with a nice processor for InfluxData as well. So both for gathering the data from the OPC-UA server to writing to Influx as well. The processor allows you to quickly configure the location and destination, the destination location for the Influx server. This could be a server at the edge where you're collecting the data. This could be a server in the cloud. It could be both. And that's really the nice piece of NiFi. Again, it's created that reliable stream. Now you can write that data so that it can be used in shaped and shared throughout the enterprise. If I now take a look at my second workflow stack, and that is just the InfluxData stack. So that is just really one processor. I've added a second processor just for error logging, but I've now gone from just taking 3 simple processors from gathering the data to writing to Influx. Lots of easy point and click instructions for configuring and setting this up. And what you'll wind up with at the end is a simple data collection workflow. And this workflow, again, is robust, scalable, secure, and all done without any coding or development work. This was all drag and drop work onto the server. The servers themselves are simple, run on the edge, requires no additional vendor or development work. So, and that's really where we're focusing the idea of working with open source solutions, taking the best of the available options for your use case and deploying them in a way that's easy, fast, and meaningful. So now I'm able to gather all that data and bring that data in, and from there, now that I've gathered all that data with tool sets, with other data exploration tool sets, I can start to shape this data and share this data amongst my enterprise, which was a big one of the big goals as I started my use case up. Now I know that the operations on my various devices and sensors, I can start to get observability on that. I can start to understand what their production life is. I can start to understand what their maintenance schedule should be, and I can start to pass this data around to others who can't reach that only windmill to view that single operation screen. I can now move all this data around. I can shape it in a way that's meaningful to the various stakeholders who are looking at this data. I can even grant further access to this data across the enterprise, share it through the cloud, so on and so on. So now this data just doesn't become locked into a local historian or a local operational screen in a lonely field. I can also start to, with other modern tool sets, I can also start to add additional information and automations to this. So we kind of talked about the idea of being able to now automate back to the devices and sensors. So we can start to create alerts and other integrations that allow for that type of two-way communication. Again, the OPC-UA framework has opened the door. Now we're providing some answers, open the door with choice. Now we're providing help and answers to how can I now best use this data to get the most out of this asset, to extend its life, to limit shadow flicker, to limit ice blade formation, to alert me when it's time for maintenance. All of this can now be accomplished because I'm able to open the doors of the data and bring it into an area where I can further process this data. And again, I'm processing all of it. I'm not sampling the data. I'm not in a loosey data format. I'm literally using the entire stack of the data stream to make these decisions. So just kind of a few. So that's really a look at how a solution can come together really quickly. All of this came together in a matter of days for deployment. So really easy. Again, no heavy commitment, no development from the side of the user and the operations team, and it was really able to meet the need, their analytical needs and the capabilities, and really extend the traditional feature functionality that they get today from their historian system, but now provide that across the enterprise, and really give them more of a complete picture, a complete vision of how resources and assets are performing, start adding that with other metadata that's available, and also integrating it with data outside of their physical world. So it allows them to act on the information from every interested party. So that's really where we see the innovation and the advantage that comes from open source, and really kind of introducing that into these type of operational environments. A few available learning resources are for that folks can draw from. Everything from additional resources on the Apache NiFi project, as well as other resources on how to get data from OPC-UA servers. There's so many different open source options available today that can be up and running in minutes, as well as more information on InfluxDB and how we work with that information, and just lots of great content on the Industrial 4.0 industry and how these industries are starting to take advantage of this sensorfied of these physical sensors that are available today. Because more and more that data stream is going to increase, and we want to be there to take advantage of the choices offered by OPC-UA and really help organizations get the most out of it. So that's the presentation, kind of taking it through and going through, and I really appreciate everybody hanging in and listening. Do want to take a moment to pause and open up for questions, but just before that, again, thank you everyone for listening and kind of hearing where we're seeing some of these operational advantages coming with open source.
Thank you, Craig. We do have time for some questions, and the audience may type questions for the presenter in the Ask a Question box on the screen, and we'll get to as many as time allows. Questions that we don't get to will be posted online at controleng.com with the archived version of this webcast. Remember to download a certificate of completion or copy of the presentation by using the Event Resources tab on the left side of your screen. And now on to the questions. Are business owners aware of how quickly these changes can be implemented and benefits can be gained?
Yes. So what I have found, and what we found quite largely, is that business owners are not aware, and that's really that's really the idea of it's concerning. But we see a great opportunity to start sharing this information now, which has really kind of prompted us to go out to organizations and start sharing some of the knowledge and background that we've gained working directly with these customers. So too often when I do engage with business owners, the first concern is that we don't have time for a project of this magnitude, or that when we do have time for a project of this magnitude, it'll be 2 years from now. So they really see that the benefits of this require so much time and effort that it's something they have to plan and thus don't take advantage of immediately. So what we're trying to showcase is these are advantages that you can deploy in a small amount of time with a small amount of commitment.
There's a lot involved here, Craig. What excites you the most as time series data collection and applications become more widespread?
So what I see more as time series is starting to spread out is data democratization, and that's really that idea that this data that's so specialized for individual systems or individual operators is now becoming more widely used throughout the enterprise. When I look at data that is focused just for an individual operation or sensor, it makes less sense at the moment unless you're a specialized user operator of that data. But now with time series data and the ability to shape your data, observe your data, report on your data, we can turn that data into a visualization and a usable template that can be passed around a larger group. And now that a larger group can interact with that data, it really opens more and invites more discussion, more use cases, more inventive ways to work with that data. So the more that time series databases spread and really are able to take in all of this very special sensorfied data, we're finding more and more ways to shape and format that data and appeal to a wider audience.
How does the data ingestion to a database work for more common industrial Ethernet protocols like Profinet and Ethernet IP?
So Typically, when I see those types of protocols and those PLCs, we generally found access to those through the OPC-UA server. So OPC-UA generally speaks to those protocols. So it gives us, again, once we're able to reliably pull that data in, we're using it in for all the different backgrounds, but understanding that there's so many different protocols for gathering that data. Also, we've seen lots of innovation from open source to create new gateways for speaking to those different protocols and bringing them into more common IoT protocol tool sets like MQTT as well. So for those specifically, I've seen those come directly through our OPC-UA server, but there are lots of different open source gateways that are also speaking that and bringing that information in.
For many applications, data collection speed is an issue. How do you collect and process high volume data streams with OPC-UA servers?
So that's really the approach that comes from selecting the combination of open source solutions. So first and foremost, in my solution set, and again, there are so many different combinations you really can bring together to address a use case, but things such as Apache NiFi are really designed to collect and gather that data, but it's really time series databases in the background that are organized by time that make for the ability to gather data at such large volume. And again, we see the value in collecting all of that data to give you a full kind of a full view of what's happening in your organization. Traditional relational data stores were not designed for that volume of data in a real-time stream. They typically at some point started sampling or batching that information across. But with the rise of time series database platforms, we now can absorb all of that information at full fidelity. And that's really part of the growth and popularity of time series databases. It's so often when I've started to engage, many people had not heard of time series databases, and now you can see it as a category be the #1 category in growth for databases across the market. So, and it's specifically that ability to gather and ingest all of that data at scale that makes it such a game changer.
Another question, wouldn't Cassandra or Mongo be a solution to time series data storage? And maybe you could explain what those two are.
Yeah, so Cassandra and Mongo are other data storage platforms available, and we have seen those in the market as well. And what we really feel with things like Cassandra and Mongo is they are themselves great solutions for the right data storage and data backend. Specifically, I think of something like Cassandra. It does come with a high level of commitment for deployment and setup and integration. One of the things we really focus on with InfluxData specifically is what we call our time to delivery or our time to awesome. So we really focus on being able to have you up and running with something like Influx in minutes, whereas Cassandra has traditionally required a lot of knowledge, a lot of expertise from someone who understands Cassandra to kind of really deliver it. Secondly, what we've seen with Mongo and Cassandra really around scale, while they do scale, because they're supporting different formats that are not just time series, we're able to do a high degree of storage optimization. So because we can do so much with the storage, because we understand the format that is time series data, we're able to write and compress that data a lot better than platforms like Cassandra and Mongo. So what might come out as 12 or 15 nodes deployment of Cassandra is 2 or 4 of InfluxDB. And again, that's because it's specialized for time series data, whereas Mongo and Cassandra are really focused on allowing other multi-form data to come into their platforms.
Great. Does Apache NiFi communicate with OPC-UA directly?
It does. It does. So as one of the plug-in processors, Apache NiFi can communicate directly with OPC-UA. And again, that's that combination of solutions. There's lots of other options you could choose from the open source world for communicating directly with OPC-UA. But what Apache really provides, again, is the data provenance. So I wanted to guarantee, not only did I want to communicate with OPC-UA, I wanted to do it securely, and I wanted to guarantee every message that comes in. So I have a guaranteed receipt and delivery of every message that comes in. So an Apache NiFi, just through its natural framework, provides those types of that type of data provenance. But many options for communicating with OPC-UA, but Apache NiFi does do it directly.
How does NiFi compare to Node-RED?
Node-RED is another great option as well. What I like about Apache NiFi, and again, I don't think it's a difference for Node-RED. What I like about Apache NiFi is that it can also scale and provide durability. So being somewhat familiar with Node-RED, I'm pointing to the features of Apache NiFi that I think really lend itself to OPC-UA and where the next challenge would be with the data, and that's also providing durability of that data, scalability of that data, being able to deploy at the edge. So I'm also kind of thinking of the very next step with that data and where that data lives. So Node-RED's a great option as well, and we've also looked at solutions kind of combining time series data with Node-RED, but Apache NiFi provided a few additional features that also allows us to kind of talk to your data durability.
Here's a question asking about the need for NiFi and InfluxDB. Can't AWS Kinesis and S3 be used for the same purposes?
They have similar features where we want to meet the challenge, and this kind of goes back to a little bit of the operational use case around the lonely windmill, and that is AWS Kinesis is delivered via the AWS cloud. So a lot of concern goes into things such as network latency. So with solutions like Apache NiFi and Influx, they can be deployed at the edge. So now I can have that at the edge, and first and foremost limit that latency. Second, because Influx is a time series database and everything is organized by time, it doesn't matter what order it comes in for us. So network latency wouldn't matter to a time series database. Once it's received, it'll instantly and quickly be organized by time. So we also see plugins and additions for options like Kinesis. But a lot of the and from the first question, a lot of the skepticism is the idea of organizations and managers worried about bringing this information directly into the cloud. First and foremost, they want to just be able to grab it at the site and start to use it. And if you have modern tool sets, modern time series databases, the next hop is to the cloud. So platforms like Influx could then send that information to Kinesis in Kinesis or other cloud platforms and hubs. But it gives you the flexibility of both cloud and edge, where Kinesis is delivered via the cloud only.
Good. Here's a question about cybersecurity. What security is implemented for the NiFi OPC-UA processors for OPC-UA server connectivity?
Yeah, so there's several different security processes you can implement within the Apache NiFi OPC connection. You can actually select from available security levels. It actually lets you choose which level you want. Everything from just kind of really basic auth security all the way down to more token-based security. So lots of different options just within NiFi itself, and it really kind of depends on where you are in your organization. A lot of this is within your walls, But I think that's where open source has really taken a leap. In the past, there was always hesitation around using open source solutions because security is such a huge part of any delivery. But now open source has caught up and provides a lot of security. So I would definitely encourage anyone to take a look at the different, if you're looking at this particular solution combination, take a look at the different levels that NiFi provides just for OPC-UA. There were several different options available. In my delivery, in working with customer, we made it really more basic, but they provided a lot of different options for securing that connection.
Great, thanks. In the presentation, you showed a couple of dashboards. What tools are used for building those dashboards?
Yeah, so in the presentation specifically, those dashboards were built inside of the InfluxDB platform. And this really goes back to the idea that there are many great options for time series that you can use for a backend of collecting this data. Where we really look at the solution is what is the ultimate goal for what you're trying to solve. So Influx provides a lot of additional features, such as being able to build custom dashboards, being able to define custom alerts and integrations, being able to query and view the data and interact with the data in real time, as well as being able to further process the data and do real-time analytics on it. So Influx provides a lot of that feature functionality just directly out of the box. But there are many other options you could use to plug in to get custom dashboarding available as well as Influx allows for plugging in other solutions to do dashboarding. So again, it comes down to focusing not on the components, but focusing on the delivery and end solution. So that's really where we like to start and work with customers. What is it that you're looking to solve? What challenge you're looking to solve? And then you can really select from a wide variety of solutions. But Influx does provide a lot of that just right out of the box.
Okay, about a minute left, and perhaps one more question. Can data in InfluxDB be accessed from other BI tools? Is the backend SQL or no SQL?
So the backend can be accessed from other tools. So we see at Influx we see a lot of additional tools used for BI backend, everything from Power BI to Grafana to business objects. We've seen a lot of different tools access for Influx. Influx leverages REST API, so it's really easy to kind of query, bring information in, and display. For those systems, all of the modern BI tool systems support REST API query for gathering, integrating data, and showcasing it today. So you really can plug in any BI tool set that you're looking to leverage for InfluxDB.
Hey, thanks everyone for the great questions. We'll try to answer the ones we didn't get to offline, and thanks again to Craig Hobbs for sharing his time and expertise today. I'd also like to extend special thanks to our sponsor, InfluxData, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on the screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcast. On behalf of Control Engineering and InfluxData, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.